So continued a little bit of the build of the OSI 502 CPU board, and I got to the state you see here with the jumpers on the back, all of the cuts and jumpers made to get this thing supposedly to work. And I did a basic continuity test, which is always smart as you work your way through, and was just trying to validate jumpers and cuts and that kind of stuff. And one of the questions I had was, there's a capacitor down here, C38, and it's got this large spacing here, which looks to me like it's more for an electrolytic, but C38 in the documentation from the previous, a builder of this called for a 0.1 microfarad disc. And that got me curious about what this was attached to. And what I discovered pretty quickly was VCC and VSS were shorted. So I'd had a short between VSS and VCC in the condition I was, and it made figuring out what this capacitor was tied to really difficult. And that led to a whole lot of head scratching and looking at documentation. I removed the pin 18 to pin 18 jumpers off the back of the board here. I looked at various trace cuts. Did a lot more head scratching, got more and more confused, which is often the case. Stepped back to think about it a bit more, redrew or added on to this build modification to start to collect where there were sockets. Did some artwork update on it to make all the pads circular or square depending on what's on the board, etc. And have I got the other piece of paper here? Not that you'll be able to see this well. But I've got I had scanned the PC board before I started assembly, and I've got the face of the board here and the back of the board here. And the back of the board's flipped so that, the pads line up. So this allowed me to, as I began to understand what was going on, to trace where the short was. And what I discovered was I had cut and made the trace link here. So cut that one and connected there. And that leads to bringing ground across to some points over here, but getting the pin 18s grounded so I can get all the pin 18s grounded, and that is output enable. And then the chip enable pin on the EEPROMs is used to actually get the EEPROM on the bus. When I got over to the side, however, I had made a trace cut here, which disconnected that from VCC, and I was supposed to make the trace connect here, a cut here. So what I had was a negative jumpers to a positive connection over here. Now I'm confused again. Which way is the correct way here? I need to cut that one. I need to relink that one back is what I need to do. Anyhow, it took a while to figure this out. I grabbed various schematic pieces. Drew in things that were connected, things like removing U17. That's what the green links here are here, though you probably can't see them, which originally inverted the chip selects. There was originally in the ROMs a positive chip enable. It now needs to be a negative. Things like that. And to verify that all these jumper links, W5, W4, etc., that they all make sense. And they now do. So really I want to get the board back to the state it was before I discovered the short. And again, this just points out why it's smart as you're building to step back and do some basic electrical tests. If I'd had the board fully populated, this may have been more difficult to figure out. So with all of that yapping done, let's cut the trace we know needs to be cut. So let me look for the X-Acto here. And I'm going to add extra light. I know this creates glare on the camera. I'm sorry. I need to make a cut here and here. As I always do, I'm going to peel out the foil so that it's obvious that's meant to be cut. Now I need to put two jumper links in. I need to put the one back in over here that I took out as part of troubleshooting, and I need to add one over here. I've got the little container of cut lead trimmings here, which is what I tend to use for this, which is why I tend to keep, let's just get a couple of leads out of it. These are nice and shiny. Do the basic bend. It's going back in where I removed one. And we're going to add one. If I can pick it up, the disadvantage of keeping your fingernails relatively short is this. And I need to put one back in here that I accidentally removed. So the genesis of cutting the wrong one is this is W8, I believe, is what that position is. W8, and there's two sets of jumper links on it, and the documentation, it said take W8A and cut the pins, which is what I did. But I realized this is W8A here and W8B here, I suspect. So I had done the wrong one. That simple. So that piece of paper is determined to slide off there to the floor. So with that done, let me get the solder here. Solder up the replacement link, solder up the correct link that I removed as part of troubleshooting. So finding power rail shorts can be really hard to do as you get more and more of the board populated. I was able in this case to do a very low resistance and see the resistance decrease as I worked my way up this direction, which told me it was most likely up here. Actually, I need to hook the pin 18s back together now. So these were a pain to put on in the first place. I've still got the same jumper links I used. Let me figure out. So U10, U9, 18. So 13, 14, 15, 16, 17, 18. Yep, that's the correct spot. Take one of the little links I worked with before. And attach to 18. Need to be really careful with this. Partly due to the fact that there's no solder mask and there are little traces between the pins here on the ICs that were in this case used by whoever laid out the board to get, the nice bus layout here. So I don't want to accidentally connect to one of those. That looks like 18 to 18, and then I believe we skip all the way over to this end there. Yep, that is correct. Luckily 18 is kind of marked here, and that there's a plate through or a via on the board that comes to it, and that via has to do with traces up to the jumper links that we just dealt with. So it goes from there to 13, 14, 15, 16, 17, 18. Oh no, 13, 14, 15, 16, 17, 18 to here. This is very fiddly. So now what I should see continuity-wise, let me get the other glasses back on, is all of the pin 18s should be jumpered together 24, 23, 22, 21, 20, 19, 18. They should all be hooked to ground. They should not be hooked to VCC. If we take pins 21, which is the VPP pin, they should all be tied together. And they should all go to VPP and not VCC. So now we are wired correctly. So that's the place we wanted to end up in. So that's perfect. It's exactly what I wanted to see. And then what we have is address decoding for the 4 basic ROMs, which is BS0 to 3 select. These jumper links on the board here are what's in green here and what's in green here. We're going to leave U17, that jumper, or W5 the way it is, because we're not inverting the signal. So that enables the monitor 2716 here. And we've got the 4 here and here, the 4 2716s for the basic. So, and this looks like it's now hooked up correctly. I'm happy with this. Default connections in W8 and W6. Basic select 1, 2, 3, and 4. There's 0, 1, 2, and 3 come in here. 0, 1, 2, and 3. So this all makes sense. The schematic makes sense. I'm happy with this. We are recovered from that issue. And we can continue on. A side note, just so it's said, is there's 2 pieces of tape on the back of the board here with arrows. And there's a little piece of loose wrap wire right here. And right here. And what those are is there's a missing trace on the board down here. And I've got a piece of wrap wire soldered on here and through that pinhole. And this will have an IC directly in the socket here. And I need to remember that wrap wire gets soldered in place there. And over here I've got a jumper link. The potentiometer here on the 123 here, I believe it is, was wired incorrectly. We removed a trace and we need to jumper link it. And there's a potentiometer that'll mount here, and again that needs to be soldered to the center pin. So by having the tape on the back, it reminds me the wrap wire is there, the mod is only half done, and that'll feed forward. You know, I never know if I'm going to get back to this today, you know, tomorrow or a month from now. So the more things I can do to help myself, the better. There is a 555 down here that is used to set the clock for the ASIC, the asynchronous communication interface adapter, the ACIA. It's not an ASIC, it's an ACIA, asynchronous communication interface adapter. It's used to set the baud rate, and I'm not going to use the component values they called out. I'm going to use the component values from the 400 CPU board we did to try to get that really rock solid 153.6 kilohertz that'll divide by 16 down to 9600 hertz here. We'll see if I can successfully pull that off. You know, comparing the layout here to the layout on the other boards are close enough. The resistors end up down here, so there's a little bit more gap. But the 50 picofarad cap will end up here and a 0.01 microfarad here. So I think this will work okay with the, the adjustment potentiometer here. I think this is going to be okay, and it's going to get me a higher baud rate, which I'm pleased with. So really, we're back to where we were at the end of the previous video. We recovered from the mistake I made, cutting this link rather than this link. Like I said, without silkscreen on the board or any indication even on the copper of what locations are, it's kind of hard to say. So really the question now becomes, what do I move on to next? There's a bunch of 470 ohm resistors that go onto the board. I'm looking to see if I thought I grabbed this stack of resistors that hadn't been put into. 470 ohm, it's these guys. So I bought a bulk amount at some point of 470 ohm. As much as I'd like to have carbon composite resistors on this, I'm just not finding enough of the values I need. Boy, that's plenty of 470 ohm. What I want to see is how stiff the pins on these are. And they are stiff. It's not that cheap Chinese, very flexible. I had seen in the forum somebody commented that he was using surface mount resistors because he was afraid because the capacitors were stood up on end. If the leads he had were too fragile on the resistors he bought and they'd be broke off. And I understand that, and that's why I wanted to check here to see just how these aren't that super soft. Probably, well, are they copper? Or they're probably aluminum. I don't know. They're, you know, I've got some cheap Chinese resistors with very soft, flexible leads, so that would be a concern. Probably, I don't know what we'll move on to next. It'll be a surprise in the next video. So whatever we're going to do next, I will see you in a future video, and we will do that. If you got this far, I appreciate it. Like and subscribe if you think the video is worthy of it. Always appreciate comments. Anyhow, appreciate your watching if you got this far, and I'll see you in a future video.